Experimental principle. Frozen tissue dehydration is a process that extracts water from tissue by the high osmotic pressure of high concentrations of sucrose. Tissue is usually dehydrated in a gradient using 3 concentrations of sucrose, 20%, 25%, and 30%. Supplies needed for this experiment: sucrose, PBS solution, EP tubes, tissue immersed in PFA, vortex meter. Analytical balance. Step 1. Configuration of 20%, 25%, 30% sucrose solutions. Weigh 2 grams, 2.5 grams, and 3 grams of sucrose. Dissolve them in PBS to 10 milliliters respectively. Use the vortex meter to accelerate sucrose dissolution. To formulate 20%, 25%, and 30% sucrose PBS solutions. Step 2. Sink tissues in the sucrose solutions. Dispense 20% sucrose solution into 5 milliliters EP tubes. Transfer PFA fixed tissues to 20% sucrose solution. The brain tissue will float in the upper layer of the solution. And then, place the sample in 4 degrees Celsius refrigerator overnight.
Many hours later.
When the brain sinks to the bottom of the tube, the first step of dehydration is completed. Dispense 25% sucrose solution into EP tubes. Remove the brain tissue from 20% sucrose solution. Then place the brain into the 25% sucrose solution for the second dehydration. The brain tissue transferred to the new solution will float up again. Store them again at 4 overnight.
Many hours later.
Completed the second step of dehydration, the brain will again sink to the bottom of the tube. Transfer it to the 30% sucrose solution, still at 4, for final dehydration.
Many hours later.
When the brain tissue sinks to the bottom for the third time, the entire dehydration process is complete. Tissues become hardened when fully dehydrated. Tips. The dehydrated tissues are recommended to be embedded soon. The embedded tissue can be stored at -80 degrees Celsius to better protect the immunochemical properties of the samples.